Okay, so graphing is good. So how do we do it in R? We're going to get a quick overview of plotting in R. You'll get more of this experience as well with the self-learn activities. There are three main packages in R for plotting. There's the core R plotting, which is good for very quick plotting. You can just type plot and then something, and often it can get something on the screen very quickly. There's lattice plots, which is good for quickly showing small multiples. So that's lots of, if you have two different variables, you can have a different plot for each combination of those different variable levels. But ggplot2 is the most powerful, and it's not really harder to use than core R or lattice. And so we are going to use ggplot2 for this course. Now, in ggplot2, plots are built up with layers. So you start the base layer, and then you start to add different elements as you need them. It's organized like this. You have the plot, which is the finished product, which is made up of different layers. And those layers are made up of geomes, bars, lines, text, and points, things that are more analogous to the marks that we saw with Munzer's outline of information visualization. So, if you want to create a plot, it's created by the layers of geomes, which are the smallest atomic units. And you have aesthetics that are moderating all of the variables across these things. It controls the graphical parameters of those geomes. So the aesthetics is where you really assign your data to the parameters of those geomes. You can specify aesthetic properties either specifically, global, or variably, connected variables in your data. So you can say color equals red, or the data equals 2, and then that will go towards the layer of the geome. And if you use aesthetic to map to a variable, you could say gender is mapped to color. Let's say you have a discrete representation of gender, then that might be a way to represent it. An experimental group might also be a good one to represent by color, or possibly location if you can afford that, etc. And so you can use AES to assign that, the AES function to assign the color to the data variable name, and then you can plot it. So let's get started. Follow along in RStudio as we do some live coding through these slides. So the first way to start is you might want to install packages tidyverse. This is a data set that allows you to really work nicely with lots of data. And then library ggplot2, which should already be installed. And you can look at the data set mpg, miles per gallon. This is a tibble, which is a table that is got some extra features about it from the tidyverse. And the first thing we might ask ourselves, what are these variables? Remember, we want to understand the data. Well, I'm going to just tell you what some of them are. Displa is the car's engine size in liters, and highway, is the car's fuel efficiency on the highway in miles per gallon. If you need more information, some datasets have documentation. For built-in datasets, you can try the help function. So if you use the question mark and an MPG, you get that information about what the MPG dataset has. And this is really, really useful for built-in ones. If not, you're going to have to consult possibly some documentation that comes with the dataset. So let's try to answer a question. Do cars with big engines use more fuel than cars with small engines? We're going to start by creating a ggplot. You say ggplot data equals MPG, and then you have a plus sign. The plus is where you start to add up those different layers to build up your plot. So let's add in geom point. This is this will do a scatter plot. It's a bunch of points on the display, and you have a mapping, which is mapped to aesthetics of x equals displacement, y equals highway. So here's where you're mapping a variable to x and another variable to y. So those values get represented visually. And if you hit enter, you should get something like this result, where you now have a scatter plot. So you've got the base plot, which you create with ggplot2. You specify the data set in the plot. So everything in the geomes that you add will refer to that data set. And then you add those geomes, which then create different layers in the plot. And in that geome, you add the aesthetic, which tells the geome how to handle the x and y values that it's rendering. You can also move the aesthetic up here. And this means it applies to all the different geomes. So now you just have geom point with no parameters, and it knows how to render it because the aesthetics are already set. And now you can start to add other layers. You can add labels, and can you guess what this does? Yeah, it updates the access labels. Now, adding labels might seem like a small change, but it's critical for understanding and communicating data. It adds the context about what these variables mean. And so I would strongly encourage everyone to always include those axes, things like units, etc. Make them descriptive, make them understandable, run them by other people to test them out. So we have our plot. What do you see? Well, overall, it seems to follow a linear relationship, at least to my eyes, but there are a few data points that don't follow this, especially over here. So what do you think is going on? Well, maybe these points are a different type of car. So let's visualize that. We're gonna go back to ggplot. We've got the command that we did before to create our scatter plot with its nice labels. Now we're gonna add another one, color equals class. That's the class of car. And you add that to the aesthetics, GeoPoint knows how to handle that, and suddenly we have this plot once you hit enter. So now what do you see? Let's focus in on that. Well, over here, we have a bunch of two-seaters. So our hypothesis was kind of correct. It looks like these cars are all two-seaters, sports cars with big engines but smaller bodies. And so they're able to, have higher fuel efficiency because they're smaller, right? But they still have that really nice engine size so they can go really zippy. So you can use different mappings than color, for example. You could say size is bigger than that. But as we've discussed, some are bad. And so you want to make sure you think through some of the earlier parts of this lesson to try and have mappings that make a lot of sense. And in fact, R will even warn you about this sometimes. Using size for a discrete variable is not advised. So think about what you graph. The key takeaways from this lesson are that exploring data is the first step to understanding it. You need to understand what's there before you start to test or conclude. And graphing data is the best way to start exploring. Summary statistics are useful, but will miss something. So you need to be careful about what and how you plot. And there's a lot of frameworks out there for thinking about this that I encourage you draw upon. So be able to visualize data using best practices. That's it. I'll see you next time.